the P star. So you have this, the other two unchanged. The last one, you differentiate this with the P star and the P over dz unchanged. So you all together, you have 5 terms. This yellow are the same. So 2, you have 4. Okay. So this one and this one already grouped because they are the same. Okay. So I will show you the steps here, but there are many things to go. Okay. So we refer back to the paper. He assumed that P is like this. Okay, P is like this. Let me put it here. Make it big. So P is like here. Okay, so I just type again. The P is gamma Z exponent I bracket 5 kz. Okay, so actually there should be a bracket Z here. But you see, in order to make your life easy, in order to make your life easy, you always want to make it as simple as possible. Right? So here, instead of write the argument bracket Z here, I throw it away. So there's no bracket here, there's no bracket here. You know that it is the function of Z. This is function of Z. All right. So this is the conjugate. Conjugate are the same thing. Okay, conjugate are the same thing. And then at the end, I drop the bracket Z. Okay, this is the conjugate. So the first trial is consider this as complex. The second trial is consider this as real. So that's why just how I said the ambiguity, the direction in order to achieve these results, the paper doesn't say gamma Z is real function of Z or complex function of Z. Okay, so that's why you need to try this one, these two. Which one will give you the answers? Okay, so again, you must use this also. So after this, with these two P's, with this P and P star, for example, if you use the first trial, so you consider this as complex. Gamma Z is a complex term. So the conjugate will look like this. This exponent positive I, this will exponent negative I if it is conjugate. So after this, you need to take the dp dz. Okay, dp dz. So I show you some steps. So complex is like this. Dp dz, first you differentiate the lambda. So this term is called lambda, capital lambda. Okay, first you differentiate this and then this unchanged. After this, you differentiate this. After this, you let this term unchanged, but you differentiate this. Differentiate this means that you differentiate the argument of the exponent and multiply with the original exponent. When you differentiate this, means that you have the I multiply with I, so that I is here. d5 over dz. And dkz over dz, you get k. All right. So you have the terms here. So is it okay?
Yes, doctor.
All right. So after this, after this, you need to do the second derivative because this equation, remember this equation, we want to solve this. So whatever terms appear, you must find it. So just now we find the dp over dz. So after this, you need to find the d2p over dz squared. So we have this, and you have to differentiate this once more. So you differentiate this once more. So I show you partially. After this, you have to find the dp star over dz, d2p star over dz squared, because you have this. right? You have the D2P star, you have the D2P, yeah? You have the DP, you have the DP star, all right? And all right, so here I just show you this. Differentiate this, you get these two terms. Differentiate this, you get three terms like this. Okay, so after this, you do the same thing for the P star. So you have two more equations. After you find all this, you substitute the P over dz like this into this position, all the dp over dz, and then the d2p over dz squared into here and into here. And after this, you need to find the dp star over dz. So you substitute here dp star. There are some more dp star. Okay, the dp star only one here. And after this, you need to what else? D2P star dz squared, right? So let me show you. You need to find the goes to question marks. So this is the dp star. Okay. And after this, you need to find the dp. Okay, equals to what? Okay. And after this, you need, okay, after you substitute all these 4, 1, 2, 3, 4 into this blue equation, you need to simplify. How to simplify? Is to use the slowly varying envelope approximation. So in this approximation, you know that when you do the substitution, you have many terms. You delete all terms carrying this. So for example, if you substitute this, then you have terms like this. So when you see the terms like this, you need to cancel the whole terms, right? So for example, you need to cancel the term with the square of the first derivative, square of this first derivative, and products of first derivative. So you need to cancel. Okay. So actually, you can make your life easy. Before the substitution, when you see the products like this, you can cancel directly before the substitution. And this term, you know that this and this cannot appear. So it seems that you can replace by this whole term by k, right? Right? Okay, yeah. And you know that this and this should be deleted if you use the slowly varying envelope approximation. And okay, before the substitution, you can replace this by k, right? And like this, you know that this square, it means that you can replace by 2k d5 over dz and k square. Because d5 over dz square, after you substitute, then you have to delete, right? So you can delete in advance. Okay, so means that, okay, do you understand what I mean? This is SEVA. Okay, right, so the term is here. The slowly varying envelope solution is easily obtained, but it's not that easy, so you have to work it out. All right, so after the substitution, no more already. Okay, so after the substitution and simplify according to this, simplify according